Hello. So from the previous chapter, like when I show you how to calculate the mean or the median, I told you that there are two different formats of information given. One is raw data, just a bunch of numbers, data, and the other is a probability distribution table or a frequency distribution table. So the how you calculate the measure should be different depending on the format of the data, like the mean and the median, and of course in calculating the variance, the how you calculate the variance should be different if the data was given as a probability distribution table. So I prepared another example where the information is given as a probability distribution. So think about a financial asset like lottery, or you may think it's a betting, lottery, like stock market, whatever, does not matter. So here there are only three possible outcomes from this investment. So you may lose $10, then which is probability 20%, and zero, nothing, there is no change with 40%, and plus $20, which is 40%. So you may lose $10, you may gain $20, or nothing. So probabilities are given. And in this case, it's a financial decision. So its measure of variability captures the risk of the investment. So now calculating the variance is the same as calculating the risk. So let's do this. Let's calculate the variance of this asset. And the idea is the same. We are going to calculate the mean of squared deviations. So we will calculate deviations and then square and then mean, right? It's a little bit more complicated, so pay more attention. First, we need to calculate the mean first. We need to define where the center is, right? So, and it is not a problem. Remember, calculating the mean, when you have a probability distribution, you have to calculate the probability weighted outcomes first. So multiply minus 10 to 0.2, which is minus 2, and multiply 0 to 0.4, 0. Multiply 20 plus 20 to 0.4, which is 8. So you have three probability weighted outcomes, minus 2, 0, 8, which sum to 6. So the mean is 6. So remember, the mean is the sum of probability weighted outcomes. That was the definition. So in this case, it is 6. The center is 6. So expectedly, this investment will give you $6, right? And then now we are going to calculate the deviations by simply subtracting the realization from the mean. Subtracting the mean from the realization. So if you lose $10, that is $16 below the expectation. So deviation is minus 16. And if there was no change, then that's still minus $6 from the expected return. And plus 20 is $14 above the return, expected return. So this way, again, we have three deviations because there were three possible outcomes. And remember, this is a transformation of a random variable. And in chapter 3, we learned even after the transformation, probability will be same in this case. So So we don't need to worry about the probability. And then the next step is to transform the deviations again by taking squares, which is simple, right? You may use calculator like 256, 36, 196. Square deviation. So we transformed the original gain loss variable into deviations and then squared deviations. You may use this new random variable together with this probability. So we are going to calculate the mean of squared deviations using this table. This is the probability distribution for the transformed random variable, which is simple. You multiply the random variable outcome to the probability. Outcome probability. So make the probability weighted outcomes again. But now here outcome is based on the squared deviations, not the original outcome. So after transformation, we calculate the mean. And then it will be 144, right? So the algebra is a little bit annoying, but not a big difference. Just if you can take take each step carefully, then it will be pretty simple. So to summarize, when you have a probability distribution table, then you have to follow these steps. You first calculate the mean so that you choose the center, and then calculate the deviations by subtracting the mean from the observation, and square the observations, and then recalculate the mean by calculating probability weighted square deviations and then sum them, right? So steps are, if you can understand the definition, then the steps are pretty mechanical. Like there is not a big problem, not much difficulty in any step. Just be careful. And by the way, in this case, when the probability is given, there is no difference between population and sample formulas because there is nothing like dividing by n. So that is already reflected in the probability. If the probability was population probability, then the variance will be population variance. If the probability was sample probability, variance is sample variance. If the probability is true probability, which is population probability, then the variance is true variance. So there is no difference in the formulas. Okay, then I'm going to tweak the question a little bit and give you a chance to do some exercise. Now, suppose that it is like if you think about investment on an asset, say there is a commission. So to make this investment, you have to pay $1 upfront. So when you lose $10, it becomes $11 loss. And even if there is no change in value of the investment, but still you have paid $1. So when you gain $20, actually your net gain is $19. So this way, I changed the numbers a little bit, and it's your turn to calculate the variance. So try the algebra and see what is the variance in this table. Pause the video. Okay, assuming that you have finished your algebra, I'm going to show you step-by-step solution. First, you have to calculate the mean. Mean, it's the same process. Multiply the outcome to the probability and then sum all the probability weighted outcomes. And the mean is 5. So, by the way, compare the mean to our previous example. Mean was 6 previously, but now it is 5, which is kind of natural because the difference is minus $1. This example is based on the previous one, but I subtracted $1 from the outcome. So mean also is reduced by $1. Not surprising at all. And then calculate the deviations and then calculate the squared deviations. What you can find here is, so remember these numbers, minus 16, so the outcomes are minus 11, minus 1, plus 19, and you are subtracting 5. The mean was 5, so you subtract 5 from each of the outcome. Then you get these numbers, and remember, these numbers we'll compare. Let's compare that with this. Same. The deviations are the same in both examples. So the same deviations, of course, then square deviations must be the same. So from this tab, everything is the same. Probabilities are same, deviations are same, square deviations are same. So of course, the variance should be the same, right? The reason is, so remember, it is about distance. So everything is moved parallel to minus 1, right? So everything has been moved by minus 1, but so that means an observation moves to minus 1, but at the same time, the center also moves to minus 1. So they are moving parallel. As a result, their distance does not change. The variance is about the distance, but because the center moves the same distance as the observations, so in the end, the distance does not change, so the variance does not change. Deviation does not change, so the variance does not change. So if you understand that the variance is a kind of a distance, then this is not a surprising result. So taking minus 1 does not make any difference in the distance or the variance. That is what we could find from this example by comparing this example with the previous one. All right. So this is one important property of the variance. We are going to study more properties of the variance in the following video, and I will use the same example in the following video. So I recommend you to continue to the following video right after this video. Okay? See you in the next video.